Hi friends, so this is the problem based on the nodal analysis. So the nodal analysis means nodal analysis is the combination of Kirchhoff's current law and Ohm's law. Kirchhoff's current law and Ohm's law. So here we need to identify the nodes. Okay, node means it is the junction of more than two elements. So I can't say that this part is a node. No, this is not the node. Okay, but I can say that this is a node because it is the combination of three elements. Node should be combination of more than two elements. So similarly, this part is also a node. And coming to this is not a node as it is the junction of only two elements. And coming to this part, this is the junction of this element, this element, this element, and this element because all the four things are interconnected. Okay, so I can consider one node here. Yes, so I need to make one node as the ground node or the reference node. So I will take this as reference node, and I need to consider this is node 1 and this is node 2. So let the voltage at node 1 is V1 and voltage at node 2 is V2. So how we have considered the loop currents as I1, I2 and I3. So here we need to consider the voltages, okay, node voltages simply. Okay, so let me go ahead. So in at node 1 I need to apply Kirchhoff's current law at node 1. So how can I do this? Please consider this is Kirchhoff's current law. So I need to apply Kirchhoff's current law at any node. So I want to apply Kirchhoff's current law at node 1. Means first this is I feel that my node voltage is more compared to all other voltages. So if voltage V1 is more compared to Vs and V1 is more compared to ground and V1 is more compared to V2, then what will happen? Obviously the current flows from V1 to everywhere. That means if I am at node 1, my current would be like this. My current would be like this, and like this. Okay, so according to that I want to write the formula. So how the current will be? So simply, yeah, current passing from V1 through 2 ohm resistor, Vs, and also ground. So once it reaches the ground, so that is the ultimate point. So that is the last point. So finally this is the concept. So how can I go ahead with that? I want to see the current through this. So what is current through that? I mean current passing through this branch, that should be according to Ohm's law, that should be voltage divided by resistance. So what is the voltage in this branch up to ground? The voltage is V1 and Vs. So how can I go ahead? V1 is more compared to Vs. That is my assumption. So V1, as I am getting positive terminal of Vs, that should be reversed. Okay, that is minus Vs. So it is V1 minus Vs. Now this is the total voltage in that branch, but I want the current in that branch, so that should be divided by resistance. Resistance is 2 ohm. And this is the current from V1 to ground. Similarly, I want to see the current from V1 to ground in the different branch. Now I am considering the branch which is having 1 ohm resistor, this branch. So how this will be? Same thing, the voltage is V1 divided by resistor 1. Of course, I can consider the voltage here as 0 volt, as this is the ground node, this is 0 volt. So simply V1 is voltage here, and here at this part also we have 0 volt only. Okay, so V1 minus 0, divided by resistance simply. So that's why I have simply removed that. Plus, yeah, what is this? V1 and this is V2. As we know, V1 is more compared to V2 as I am at node 1. So V1 minus V2 divided by the resistance is 2, which is equal to 0. Yes. Now I want to make this as simple. So let me multiply it with 2 here and with 2 here, so that 2 will be my LCM and it will go off. And I want to write this equation as multiple of V1 first and then V2, after that any other thing. So multiple of V1 is V1 plus 2V1. So summation is 3V1 and this is also 1V1. So finally it will be 4V1 minus is there minus V2 is equal to Vs. So I want to send this Vs to the other side. So this is the concept here. At node 1 we need to consider like this. So similarly the same thing we need to go ahead with node 2. So at node 2 again the application of KCL. This is very simple. So at node 2 also I need to feel in the same manner. So I am at node 2. So my V2 is more compared to V1 now. So I am considering like that. So current is flowing in this way now. So this is simple assumption. So once you solve the problem, you can definitely know which one is more. Okay, no, that's not an issue. So currently you can assume like that. So simply first one V2 minus V1 divided by 2 plus, I mean this branch. Now I am considering this branch. So this is V2 divided by 1 plus V2 divided by, so the total resistance is 2 ohm and 1 ohm here. So it will be V2 divided by 3 is equal to 0. So is equal to 0. So actually in general we need to, of course, uh, we need to write in the same manner V1 by 2. So it will be minus V1 by 2, or you can take LCM also. So let me take LCM here so that it will be very easy for you. If I take LCM 6, then 6 means it is 3V2 minus 3V1, and here it will be 3V2, and here also it is 2V2. Okay, let me write here, no problem. So this will be 3V2 minus 3V1 plus 6V2 plus 2V2 is equal to 0, which implies minus 3V1 plus 6 plus 2, 8 plus 3, it's 11V2 is equal to 0. That's all. So these are the two equations we have obtained. Now we can solve this equation for anything, but the problem is very simple here. So we no need to solve this. So we can solve in a simpler manner, but in general we can adopt the matrix method to solve this, because that is the easier method compared to other methods. So let me do it. Yes. So my problem is, actually this has been given. So I need to consider, I need to find Vs in terms of V. So according to Ohm's law, we can say one thing. So according to Ohm's law, so the current passing through 1 ohm resistor, let me consider this as I. So I is equal to voltage V divided by resistor 1, which is equal to V. So the current passing through this resistor is I, and that is V. and the same current is flowing through this 2 ohm resistor also. Okay, let me write this. So I want to consider, I want to make, I want to derive V2 in terms of V now. So what is V2? V2 means it is the summation of voltage at 2 ohm resistor and also 1 ohm resistor. As the current is V, so 2 ohm resistor 2 into V plus V is equal to 3V. So the voltage V2 is simply 3V because voltage across the current passing through this is V and voltage across this 2 ohm resistor is 2 into V simply. Of course, the voltage across this resistance is always V. So it is 3V. So V2 is 3V now. So please substitute this V2 here so that you will get V1. So substitute the same thing. Let me write here. This is second equation and this is first equation. So substitute the same thing in second equation so that it will be 3V1 plus 11V2. So 11V2 is 3V here. So which is equal to 0. Therefore V1 is equal to 3 minus 3V1 can send to other side. So that will be plus 3V1 which is equal to 33V1. V. Okay, we can remove 3 and 3 here. So V1 is equal to simply 11V. And substitute the same thing in the first equation. Okay, so that will be equal to, so first equation implies 4V1, so 4 into 11V minus V2, so V2 is 3V is equal to Vs. So finally we can say that therefore Vs is equal to 44V minus 3V is equal to 41V. That's all. So this is the nodal analysis. So by using nodal analysis we have solved this problem. So if you have any doubts, you can simply type in the comment box so that I can attempt for the possible answers. Okay, so please do that and please try to subscribe as we are planning to finish this network analysis, both theory and practice, within the 2 months only. That means up to the February we can complete the network analysis. So please try to follow so that you can finish it off within stipulated time. Thank you so much.